So if we have terms like, we're going to add them up. So we have a sub 1 plus, and this is a geometric sequence. So a sub 1 r plus a sub 1 r squared plus, and then we just keep going until we get to the general term, a sub 1 r to the n minus 1, right? So that's what we've been working on. We've been doing some sums with these geometric sequence terms, right? We're just adding them up. And so we said, well, there's a sum that we can, get from a formula. But what if we keep going? What if it doesn't stop at n terms and we just go what's called an infinite. So let me put the word infinite here. An infinite geometric series. Okay, so now we're adding these up and it's going to infinite, like infinity terms. Sometimes they will label this with an S and they won't put a subscript. So they're talking about the sum of that many terms. Okay. Now, it's called, well, let me erase that. That's going to come later. So it's called an infinite geometric series, though, where we're adding these up and it keeps going and going and going. All right. So sometimes there's a sum, sometimes there's not. If r is bigger than 1, and I should say the absolute value of r is bigger than 1, because r could be negative. And we had some where we had negative sequences, geometric sequences. So if the absolute value of r is greater than 1, then these terms are just going to get bigger and bigger and bigger, right? And they get bigger fairly quick. And you're adding them up, so that total is getting larger and larger and larger, right? Okay. But if r, the absolute value of r is less than 1, then the value is getting smaller and smaller, right? We saw that when we had a sequence and it was like 9 and then 3. It was negative, but it's okay. And then it was 1 and then it was 1/3. And so if you were adding those up, you keep adding a smaller amount, right? So you see, like, and it just keeps going. So R in this case was 1/3, which is less than 1, right? Okay. So that's what's going on here. So you're adding a smaller and smaller amount. So if you look at your sum formula, so the sum of n terms, we had a formula for that. 1 minus r to the nth over 1 minus r. But now what's happening is this part is getting smaller and smaller and smaller. So r to the nth is approaching 0, okay? As you're going to infinity, that r value, you keep multiplying it, and it's going to get smaller and smaller. You keep cutting it, like in that case, 1 by 1/3 every time. And so it's approaching 0. So because that's going to 0, then we have the formula for the geometric series. I wanted to go back. Okay, we're going to say the sum of an infinite geometric sequence where the absolute value of r is less than 1. It's going to be just that a sub 1 times 1, but you don't need the times 1 because this part's going to 0 over 1 minus r. So what we usually write, we write the formula like this. S is equal to a sub 1 over 1 minus r. And I don't remember if they use an S, but that doesn't have a subscript, so it's an infinite. They might put S sub infinity. I'm not sure if I remember that. Okay, so yeah, they use the S. So remember, you can have the sum of an infinite geometric series, but it's only if your absolute value of r is less than 1. If the absolute value of r is greater than or equal to 1, there's no sum for the infinite, for infinite geometric series. Okay, so this has to do with an example, well, I won't do it here. But like say you have a piece of Thanksgiving pie, right? Like you have a whole pie, and the first day you eat half of it, and then you eat, so half of it's gone. And then you eat a fourth of it, right? And then you eat half of that, and then you only have that much left, and then you eat half of that. Are you ever going to eat all the pie? Well, yeah, in theory, you're going to eat all the pie, right? But it's getting, you can't keep cutting it in half. Eventually, you're going to have eaten one whole pie. Okay, so that's kind of the idea there. It says find the sum of the infinite geometric series. Okay, so here's our series. We have to find r. So what you do to find r is you take two consecutive terms, and you're going to say negative 3/16 divided by 3/8. Okay, and then that means negative 3/16 times 8/3, right? Keep, change, flip. The 3's cancel, and so we get negative 1/2. Now, that is the absolute value of negative 1/2 is less than 1. The absolute value of negative 1/2 is less than 1. So yes. So it's an infinite geometric series with a sum. Okay? So now we can use our sum formula that we just learned. I like this formula because it's fairly simple, it doesn't have a lot of things going on. Okay, now, what is a sub 1? Well, you know that from the series, it's 3/8. And then what is r? R was negative 1/2. Okay, so you're going to have 3/8 over 1 plus 1/2, which is you're going to have to get a common denominator, and things like that. Or you just might know 1 and 1/2 is 3/2. Okay, so keep, change, flip. And the 3's cancel. 2 goes into 8 4 times. So you're getting 1/4. Okay, so that is the sum. That is the sum of the infinite geometric series that we had, 1/4.